Hello friends, I am Ram Goda and welcome to my another video lecture on computer algorithms. The topic that we are going to discuss today is optimal storages on tapes. This is one of the greedy method. I request you that after watching this particular video, please go to the description section and attempt the quiz that I have provided into it. Also, I request you to share this particular video series to your friends. So friends, let us move ahead and let us try to understand what is this optimal storages on tapes. So in a optimal storage on tape problem, what we have given is we have given a sequential tape. So there is a tape and this tape is used for the purpose of storage. Let us say there is a sequential tape. Now a sequential tape means the data is stored in this particular tape in sequential format. Okay, so in the sequential format means if you have two files and the first file is placed at the first position and second file is placed at the second position, you cannot access the second file without accessing the first file. So here there are n programs. What is the problem definition? Let us try to understand. There are n programs that are to be stored on a computer tape of length L. The length of this particular computer tape is L. Associated with each program I, for each program I have to store n programs. So any program I is between 1 to n, any program I where I is between 1 to n, there is a length Li. Okay, then clearly all the programs can be stored onto the tape. In what case? If let us say the length of all the programs, sum of length of all the programs, if it is less than the length of tape, then in that case I can store all the programs onto the tape. So that means that clearly all the programs can be stored onto the tape if and only if the sum of the lengths of the programs is at the most n. We assume that whenever a program is to be retrieved from the tape is initially positioned at the front. So this is the front position. Then if the program are stored in the order I is equal to I1, I2, I3, so on up to In, and the time Pj needed to retrieve the program Ij. So let us say I want to retrieve the program 3. So j is equal to 3. Then it is proportional to sum of all the files from length of ik. That is, I have to find out the length of the file 1, which is at the first position, length of the file which is at the second position, and length of the file. If I am finding out it for the third one, I want to access the third file. At the time I have to access all these three files. That means that the time required to access this particular file is, let us say, if the length of first file is 5, second file is 6, and length of third file is 3, at that time, in order to access the third file, I have to wait for 14 seconds, let us say. So if all the programs are retrieved equally often, so if the probability of accessing each file is equal, then what we can do is we can expect the mean retrieval time. And what is the mean retrieval time? Mean retrieval time is sum of all these the time required to access all these files divided by n. Then in the optimal storage on tape problem, we are required to find a permutation for the n problems, so that when they are stored on a tape in this order, the MRT is minimized. So what we want to do is we want to store the files onto the tape in such a way that the mean time to retrieval time should be minimum. I want to minimize the mean retrieval time. Now this problem fits into the ordering paradigm. We have discussed some of the problems called as subset paradigm. So I wanted to find out some subset in case of knapsack problem, in case of job sequencing with deadline problem. So they were all subset paradigm. Here I want to find out an ordering, in which order the files are to be stored onto the tape. So this problem fits into the category of ordering paradigm. Minimizing the mean retrieval time is equal to minimizing the total storage time, that is called as DL, and that is sum of all the files, accessing all the files, and this sum we want to minimize. So let us take an example and let us try to understand what is this. So there are three files. Let us assume that there are three files, n is equal to 3, and the length of three files are I1, L1, L2, L3 are 5, 10 and 3. So in order to store three files onto a tape, let us assume that the tape length is greater than the total cost of these files. So there will be 6 possibilities. So there are n 3 factorial, that is 3 factorial is equal to 6 possible orderings. So for 3 it is very simple to find out all the possibilities, but if there are 100 files, so in that case I have to find out 100 factorial possibilities, and out of that I can select the smallest one. So that is not a feasible way of solving, but let us try to understand this particular method. So when I store the ordering as 1 2 3, that is first file is placed at on the tape, first file is placed at the first position, second file is placed at the second position, and third file is placed at the third position. So total time required for all the files. So if you want to just access the first file, you will be you have to require the access the first file, and length of the file is 5. If you want to access the second file, in that case you have to completely access the first file, and then you have to completely access the second file. The total time required to access the second file is 5 plus 10. For third file, if you want to access the third file, in that case you have to access, and let us assume that your tape head is at the beginning. So in that case, in order to access the third file, you will require 5 plus 10 plus 3, that is this much amount of time. If this is the ordering, if ordering is 1 3 2, that is first I am storing the first file with length 5, then second file with length 3, and so the files are stored here are 5 3 and 10. So that is 5 for the first one, for the second one 5 plus 3, for the third one 5 plus 3 plus 10. If this is the ordering 2 1 3, in this case it will be 2 is 10, 1 is 5, and 3 is 3. Length of the third file is 3. So it will be 10 for the first file, 10 plus 5 for the second file, 10 plus 5 plus 3 for the third file. Similarly, if the ordering is 2 3 1, in that case it will be 10 3 5. So in that case again it will be 10 10 plus 3 and 10 plus 3 plus 5. 3 1 2 is 3, then 1 is 5, and the third one is 10. So in that case, time to retrieve the first file is 3, time to retrieve the second file is 3 plus 5, time to retrieve the third file is 3 plus 5 plus 10, and similarly 3 to 1. Now if you see the cost of traversal, if you identify what is this sum, so it comes to be 38 over here. For this it comes to be 31. For this it comes to be 43. For this it comes to be 41. For this it comes to 29. Last one is 34. So what we wanted to do is we wanted to minimize the mean retrieval time. So what is the mean retrieval time is this cost divided by n. Now n is 3 here, so it comes to be this one. Now out of this the optimum solution is 9.66. If you'll see here what is the storage criteria, in what way the particular storage is done, you can find that the smallest file is stored at the first location, next smallest file is stored at the second position, and so on. The files are stored, in short, what I want to say is the files are stored in the increasing order of their sizes. So this is the solution. So in order to solve this, what we have to do is we have to store the files into the increasing order of their sizes. This is with the one tape. Let us try to know about what if there are multiple tapes. So let us say again, the files are given to be stored, but there are multiple tapes now. There are 3 tapes now. Let us assume that in this particular example. So let us try to solve this particular problem with multiple tapes. It may sometime happen that you have given multiple tapes, and on these multiple tapes at tape number 1, if I store a file, first file, so the time required to access this particular file is the length of this particular file. Second file I can store at the second position of T0, and the time required to access this file is time required to access the first file and time required to access the second file. But if I store the third file onto the first position of the second tape, at the time required to completely access this file is length of this file. So what is the benefit I am going to get over here is, if I store the third file at the third position of the first tape, it is needed to retrieve the first file, second file and third file completely. But instead of that, if I have a multiple tapes, I can store this one onto the first position of the second tape. So if multiple tapes are given, what you can do is, and if you have given n files, in what way we should store? First of all, what we have to do is we have to sort these files into the ascending order of their sizes. Let us do that. So the smallest file here I can find out is 3, then 4. Let us say this 3 is gone, 4 is gone, 5, there are 2 5s. Then we have 6, 7, 8. We do not have 9. We have 10, we have 11, we have 12. One file each of length 10, 11 and 12. So total there are 13 files. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 are done. Another 3. One is 32, 18, 26. So next would be 18. Next would be 26 and the final one will be 32. These are the 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 files. So if you have multiple tapes, tape T1, T2 and T3. The first file I store on the tape T0. Second file I store on the tape T1. Third file I will store on the tape T2. In the round robin manner, next one I will take the next file or to the next location and at the second position, round robin. So allotment I will be doing in the round robin manner. Then next one is 6 over here, 7, 8, 10, 11, 12, 18, 26 and 32. Now in order to access all these files, what will be required is it will be 3 plus 5 plus 3 plus 5 plus 8 plus 3 plus 5 plus 8 plus 12 plus 3 plus 5 plus 8 plus 12 plus 32. So this is the total time required over here, and we can calculate it as 3 plus 5 is 8, 8 plus 3 is 11, 11 and 8 19 and 8 27, then 30, 35, 43, 53, 55, 58, 63 and 8 comes to be 71 and 12, 83, then 83 plus 30 comes to be 93, 103, 113 and 105, 115. Time over here is 115. The mean time to retrieval over here is 4 for the first file, 4 plus 6 for the second file, 4 plus 6 plus 10 for the third file, and 4 plus 6 plus 10 plus 18. 4 plus 6 plus 10 plus 18. Now here we have to do it for only for the 4 times because there are only 4 files. So it comes to 14, 14 plus 4, 18, 24, 34, 38, 44, 54, 64 and 8. 64 and 8 comes to be 72. For the third one it will be 5 plus 5 plus 7 comes to be 12. Then 5 plus 7 plus 11 comes to be 23. And 5 plus 7 plus 11 plus 26 comes to be 23 plus 26, 49. 23 plus 26. So this comes to be 5 plus 12, 17, 17 and 40, 89. So total time required over here is, this one, and mean time to retrieve these files comes to be 115. So total time required is 115 plus 72 plus 89, and that comes to be around 185, 187 and 267 and 9, 276, and mean retrieval time is 276 divided by 3, and that comes to be 92. Mean retrieval time is 92 for each file, Let us try to understand the implementation. So implementation is very simple. So algorithm store, there are n files and there are m tapes, multiple tapes, m tapes. So in the previous case there are 3 tapes and 13 files. So n is the number of programs and m is the number of tapes. And let us assume that the programs are stored in such a way that they are already stored in ascending order of their sizes. Then j is equal to 0. So next tape, there are 3 tapes. Which are the 3 tapes? In the previous case 0, 1 and 2. If there are 4 tapes, you can change it up to this, but intentionally I have considered 3 tapes with the numbering T0, T1, T2 because we want to start from the indexing from 0. So j is equal to 0. Now for j, I is equal to 1 to n, do, right? So printf, append the program I, append the current program to j. And then what we have to do is j is equal to j plus 1 mod m. So that is first program will be appended here, then next program will be appended j plus 1 mod m, j plus 1 mod m, and next program will be, there are 3 tapes, so j is 2, 2 plus 1, 3, 3 mod m is 0. So next program will be appended here, so in the round robin manner. This is how the particular storage is done. If you want to know what is the time complexity of this, problem is in terms of n, because there are n files are to be stored. So space required for that is n plus 1 amount of space is required for n, 1 amount of space is required for number of tapes, then for j and all these things, j1 is required. So the total space complexity is n plus 3, whereas the total time complexity of this one, since we require to rearrange all the files into their all the files into the ascending order of their sizes. So ascending order means it will be n log n if you are using the merge sort or heap sort, and it will be n square if you are using the bubble sort or any insertion sort. So that's up with this particular video. Next video will be optimal merge pattern, and I request you to go to the description section and attempt the quiz. Thank you for watching the lecture.